Hello, my loves. Welcome to this week's homework where we are looking at square roots and cubed roots. And we're going to go ahead and jump right in. So just a couple of reminders. It might be helpful, beneficial to you to just have the first few squared roots and cubed roots written down just for quick grab and go. And just as a reminder, those are your numbers multiplied by themselves or using that exponent. So 2 times 2, 3 times 3, 4 times 4, 5 times 5. Just having those as a quick grab might be a little bit easier for you. If you don't want to, though, you don't have to do it. So let's take a look at these. If these are not a perfect square, we can factor them out. Some of these should look familiar. I gave you some friendly ones. So I can't do the square root of 12. It's going to be in between the square root of 9, which is 3 times 3, and the square root of 16, which is 4 times 4. What I can do is factor it out to the square root of 3 times 4. Let's make this a little bit thinner there. 4 is a perfect square, so the square root of 4 is 2 because 2 times 2 is 4. I can factor this out to 2 square root of 3. For this one, there were 3 options that I thought you could possibly have come up with. Square root of 9 times 12, square root of 36 times 3, or the square root of 27 times 4. 9 is a perfect square. 3 times 3 is 9, square root of 12. 36 is a perfect square. 6 times 6 is 36, square root of 3. 4 is a perfect square. 2 times 2 is 4, square root of 27. Any of those 3 would be perfectly fine. Coming down here, square root of 4 times 5. 4 is a perfect square. 2 times the square root of 5. So 2 times 2 is 4. That's our perfect square. Write it with what else we have left. 98, I can break that down into 49 times 2. 49 is a perfect square because 7 times 7 is 49. So 7 square root of 2. This one looks a little bit different. Strategy still the same. I can break 45 down into 9 times 5. 9 is already a perfect square. This is where it gets a little bit tricky. 3 square root of 5 makes sense, right? 3 times 3 is 9. 3 is a perfect square, so we can put the 3 here. These cancel out because we could do 3 divided by 3. Square root of 5 is our final. If you had trouble with that before we talked about in class, completely understand. If you have questions, bring them with you. This one I put in the classroom to make it 25 on the bottom, to make it a little bit of a friendlier square root, because then they would both be perfect squares. 49's perfect square is 7. 7 times 7. 25 is 5, so we can call this the square root of 7/5 or 7/5. Over here, let's go up to the top so it sticks with the way that you're used to. Square root of 81 times 2. 9 is the square root of 81. 9 times 2. 200, we can break that into 100 times 2. 100 is a perfect square. 10 times 10, square root of 2. Over here, we can break that down into 169 times 2. This is a perfect example of where having those first set, I would probably go up to 15s. First set of square roots is going to help you because you might not know that 169, its square root is 13. 13 square root of 2. Over here, 64 times 3. 8 square root of 3. 8 times 8 is 64. And then this one, square root of 16 times 6. 16 is a perfect square. 4 times 4, square root of 6. Last one down here, I can break 363 into 121 times 3 over 4. 121 is 11 squared. And 4 is a perfect square. So 11 square root of 3 over 2. If you have any questions on this first page, please don't hesitate to bring them with you to class. I know you are so excited when you saw that we could do equations with perfect roots. Let's do it. So if I want to solve an equation, my goal is to get the exponent, or I'm sorry, not the exponent, the variable by itself. So here I have x squared. The opposite of squaring a number is the square root. So x squared, its square root is x. 400's square root is 20. Or this could be negative 20 because negative 20 times 20, or negative 20 times negative 20 is 400. 20 times 20 is 400. So it could be either positive or negative. To the cubed, it's not going to work. Can't be positive or negative, but with our squares it can. So cubed root, this is where it might be really helpful to have that first couple of sets, because you might not know that 5 times 5 is 25 times 5 is 125. But if you have it written down as a quick reference, it might help you. All right, square root of both. X is equal to 17 or negative 17, because a negative times a negative is a positive. Cubed root. X is equal to 10, because 10 times 10 is 100 times 10 is 1,000. Square root. She's not perfect, but she tries her best. 81 times 3. 81 we recognize as 9 times 9. X is equal to 9 square root of 3, or negative 9 square root of 3. Either will work. Over here, I can break this into 400 times 2. 400 can be broken down into 20 square root of 2, or negative 20 square root of 2. Both of these are equal to x. Let's go on this side, go up to the top. Here we go. All right. Square root. X is equal to 16 or negative 16, because 16 times 16 is 256. Negative times negative is a positive. Over here, I don't have a perfect square for 300, but it is the same as 100 times 3. And 100 is a perfect square. 10 times 10 is 100. Square root of 3 comes down with me. I can also say negative 10 square root of 3. This one is not going to be perfect, but that's okay. Actually, it is. 8 times 8 is 64. Oh, this is a good one. X is equal to 8, because 8 times 8 is 64 times 8 is 512. Winner, winner, chicken dinner. All right, square root. X is equal to the square root of 4 times the square root of 6. X is equal to 2 square root 6, or negative 2 square root 6. Down here, this is not going to be a perfect cube. This is equal to the square root of 4 times 6. I'm sorry, cubed root. Wait, rewind. Thinking of square roots, which was the one right above. Cubed root of 8 times 3. Let's do that one. Because 8, we could do 2 times 2 times 2. So 2 cubed root 3. All right. Another cubed root here. Make sure you're putting that teeny tiny little 3 up on the top, as much of a reminder to you as it is to me. X is equal to, we can do the cubed root of 125 times 3, because 5 times 5 is 25 times 5 is 125. So X is equal to 5 cubed root 3. If you have any questions, please do not hesitate to bring them to class. All right, last page here. Oh, look, she wants us to list the perfect squares. Seriously, take the time. Do it once. Don't do it every time. But take the time and write these out. Just take the first 15. I know it seems like a lot, but it will help you. 16, go wild. 20 perfect squares and perfect cubes. It's going to be so much easier if you can just grab and go. So this time I just asked for the first 4. 1 squared, 2 squared, 3 squared, and 4 squared. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. Over here, first 4 cubes. Remember how our exponents work. 1 times 1 is 1 times 1 is 1. 2 times 2 is 4 times 2 is 8. 3 times 3 is 9 times 3 is 27. 4 times 4 is 16. 16 times 4 is 64. What is the difference between a square root and a cubed root? A square is a number times itself. Cubed root is a number times itself twice. So this is going to be our square root, and this is going to be our cubed root. Last couple down here, simplifying them out. 72 is not a perfect square, but I can break it down into 36 times 2. 6 times 6 is 36. It could be the positive or negative version because it is squared. 324 is a perfect square, so this is negative 18 or 18 because 18 times 18 is 324. Over here, 80 is not perfect, but 16 times 5 is pretty fantastic. 16 is 4 times 4. Square root of 5, don't forget, be positive or negative. And then last one down here, these are perfectly perfect. I can break this into 25 times 3 over 25 times 2, which would be 5 square root 3 over 5 square root 2, which would be the square root of 3 over 2. Technically square root of 2. Let's get it right. All right, questions, comments, concerns, confusions, bring them to class. Otherwise, have a good